this one, these two, they're the smallest length, no, which I can measure it. I know how much it should be equal to. I think if you start reading 0.1 centimeter, 0.2, 0.3, 0.4, 0.6, 0.8, 0.9. Oh, what happened? 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. Okay, fine. This is. What is the smallest length? Shall we put 0.05, 0.1 centimeter divided by 2? That's the smallest length. So delta X, how much I can measure? 0.05 centimeter. I think that's a good scale, no? You open in geometry box. Do you get this scale? No. So what is the scale? You'll get only 10 divisions. In 1 centimeter, how many divisions are there? 20 divisions are there. This is the smallest length I can measure. I want to measure the length of the rod. There's a rod whose length has to be measured. No. No. What you say? Like there's a rod. Its length has to be measured. So what is the length of the rod? So what is your comment? And we'll go for the counting. 2.1, 2.2, 2.3, 2.4, 2.5. 2.5 is what I'm very sure, no? Then what you're going to do? Is it, so this is the 2.5 till here. And what is this? 2.55 and this is 2.6. I'm going to write the values. Okay, this. Sorry. It is. If you want, we'll magnify. What is there in that one? We have magnifier also here. Able to see this? No, come for this one. So what we are very sure. 2.5. What we are very sure? 2.5 and 2.55 is here, no? So which decimal place you are very sure? This 5 is very sure. Then afterwards what happen? So in between. So what we do? We just make a guess, no? So in between, what is this distance? 0.05 centimeter. And look at this particular line. So what shall I write? Length of the rod. 2.5, I'm very sure. So I'll check this edge. Okay, it is coming something like this here. So shall we put 2.57? Because if the edge were here near to this, I would have wrote 2.53 something. It's almost near to this, 2.57, all right. So tell me like what we have made a guess. Length of the rod. 2.5 and the guess what I made is this one. No, I wrote in some color that 7. Which one you are more confident? I think we are more confident of 2 and 2.5, no? 2 and 0.5, that one. We are not very confident. Which are reliable? These two are reliable. And what about this 7? not reliable. So what are significant digits? The sum of reliable and not reliable digit, or least significant digit and most significant digit. This one. So like in between, how many are there? So this is the most significant digit, this is the least significant digit, and in between also we'll count it. So everything open will become significant figures. This 7, is it significant? Yes. No, no sir, like a, but it's a error. Yes, I know it. No, it can be 6 or it can be even like a 8, but at least, okay, some, it will have value. So it's also, though it's not a reliable, still what happened? I have to enter this particular observation, or will you write only 2.50? I think it'll be wrong, no? Sir, why not you write 2.5? Tell me, I think you are in a big trouble, no? At least tell me where error. Error is more here, more error. At least your error will become less if you write 2.6 or 2.8. So therefore, what we have to do here, the reliable plus not reliable digit are called as significant figures. So this is the idea of that one. Or next you can ask question, so what is use of this? See, like when you write significant figures means how to express a reading. Suppose say like somebody says like the length of the rod is, another student. So one student is written. Another student, you use another scale and you say that the length of the rod is 2.5734 centimeter. Now tell me like what is very sure? Is very sure about 2, 5, 7, and 3, and is not sure about this. So this is not a reliable, but this everything will become significant figures. So don't think that only 2 and 5 is significant. No, even this is a guess. Like that, what you should not write. Means you did measurement. If you write like this is what reliable. And this is what guess. So therefore we'll say unreliable. So what is significant figures? All this sum of reliable plus unreliable is significant figures. So what is the use of this? Tell me, like if I write like this, what does it mean? The student has used a scale where the least length you can measure is how much? I think it's a very good scale, no? So tell me like the significant figures indirectly what it will indicate. Shall I say precision of an instrument? Are you getting the idea? It will indicate what? The precision of instrument means what is the type of instrument is used for this measurement. So what is the science? The science of measurement, what it says, like when you write answer, your answer should reflect what type of instruments you have used. Okay, okay, my weight of the body is also like a mass of the body is if you say 20 kg, if you use another weighing scale 20.34, or say mass of the body, that one. If you use another scale where it is tell me like a which scale is good, this one, no? If you write like this, what does it mean? Okay, you are using some good scale where your weight is measured accurately up to the third decimal place. Of course, this is a guess. Now, what is a guess? This 0 is a guess. You may write 21 or you may 19. Tell me like, which is good scale, which is a good instrument, this is a good instrument. So like that. So the science of measurements, what they made a rule, the measurements, what you make and what you write answer should reflect the type of instrument. So shall I put like this? So the significant digits, what it will tell us, in that it will tell us the precision of instrument. Okay, fine, all of you. So I'm just explaining the core idea. The rest of everything already we know some rules, everything will follow that. So let me get this one. So you can select it. There's a very good instrument. So definitely what happened. Yeah, this is also a very good instrument. So what is the significant figures? SGF, I'll write in short. The sum of reliable and unreliable digits. are called as significant figures. Finish or nothing that one. Now what happened? Suppose you measure the length of the rod and you should not write like this. Huh? I think this will be something wrong. 2.57384.9. If you write end answer like this, what like a scientist will think? You have designed a such a scale where up to 1 micrometer you can measure. So therefore, I think we should control our decimal places. No. So the based on the instrument or pen, you should reflect the final answer. I will write that one. This discussion is now there in the book. So they may ask you conceptually. The measurement observed should be entered in such a way that it should reflect the precision of instrument. Okay, there's a core idea. Okay, now we'll go for the rules. How to identify number of significant figures? This one. So some rules are there. We'll formulate the rules. This if you know in chemistry, okay, I'll skip it. In chemistry, I think you might have come across. You don't have in chemistry. Huh? Okay, fine. I'll continue that one. First one. Okay, fine. I'll carry on. I'll explain in detail all the rules, everything. Okay, there's no more any comments. Huh? Let me proceed that one. Huh? Okay, all non-zero digits are significant. All non-zero digits are significant. So example, I'll write it irrespective of decimal place, everything. So 42.3. How many are there? Is having 3 significant digits. So shall I write 3 only here? In the bracket, I write 3 significant digits here. It's not that 42.3 is equal to 3. The bracket, what I put, number of significant digits. So now 238.65, number of significant digits. This one, 1.3342, number of significant digits, 4. Or if I write 28, 2. If I write 1.3, it will be 2. All non-zero digits are significant here. Okay, we'll take the second rule. No, trailing zeros or the zeros placed to the left of the number are significant. Means if it is like this, 3.800. Number of significant digits 4. 3, 8. Okay, next again. 38.0. So this is significant. Trailing zeros or zeros placed to the left of the. Somebody was asking, somebody was telling.
Sir, zeros placed to the right, no, sir.
Okay, placed to the right of the number. Placed to the right of the number are significant. So even, so there's about that thing. So I will write like this, 240 centimeter. So this 0 is significant here. Now, if I write only 240, then open 0 is not significant. Means if a 0 comes from the measurement, then it's said to be significant here. If you just write without units, it's not significant. I think we never do, this is of no discussion, that's why the books they are avoided. So this will never do any measurement where suppose a strain, if you take it, no, change in length by original length. Is there what happened? So this, we have to be careful in expressing such quantities where there are no units are there. So this 0, what happened? If it comes from measurement, it will become significant like this. If this doesn't come from measurement, no, it's not become significant. So therefore, what is the simplest thing? The trailing zeros are there. So this one, we think that only this is significant here, because according to definition, all non-zero digits are significant here. But the 0 has come due to measurement. So therefore, this must be significant. Here, what happened? I'm not writing any unit. So therefore, it will not be significant here. So if a trailing zeros appear due to measurement, they are significant. If the trailing zeros are not due to measurement, they're not significant. This is one rule, is what they have made it. Third one will make it. Leading zeros or the zeros placed to the left of the number are never significant. So this 0, what happened, will not be significant. Okay, I agree this. So this 0 will not be significant here. These are called like leading zeros. Now, if a 0 lies between two non-zero digits, it must be significant. The next one more rule I'll make it. A 0 is significant if it appears between non-zero digits here. So now 408, 3 are there. So now 44008, 4 are there. 31.012. The 0 is significant. Then 28.102. This will be significant. Okay, I think I'm showing it almost all the cases. A 0 is significant if it is appears between non-zero digits. Now, there's a one more rule. Okay, somebody, okay, just if you just see once, I'll scroll down. Okay, if I think these are very simple rules, nothing to do, no concept, nothing, just the certain rules are there that you have to follow it. And now after this, we'll go for the scientific notation. So how to express a number in scientific notation. So a number always you have to express in terms like this. So where the A, what happened, the value of A should lie between 1 and 10 or less than, or should be greater than or equal to 1 and should be less than 10. So this is one scientific way of notation. So suppose if I write first number 2.1 into 10 to the power of 6. So how many significant digits are there?
2, sir.
2 significant digits are there. Okay, now what is this A into 10 to the power of B? The B is called as order of magnitude. I'll give certain name for this. The B is called as order of magnitude, and it will not have significant figure. And what is A? A is called as a base. So A is called as a base. That one only it will have significant figures. Only it will have significant figures here. So 2.1 is what I'm expressing that one. So clear this. So there's a way of expressing in the scientific notation. So bigger numbers, what happen, you should express here. Next one more will say significant figures will not change due to change in units. Now 100 centimeter is there. I want to convert into meters. Tell me how I should write. Okay, I'll start with a very simple 125 centimeter. I want to convert that into a meter. So what is the conversion? 1.25 meter. How many significant digits are there? 3. How many are there? 3 must be reflected. So due to change in units, you should not change the significant figures. And now if it is 100 centimeter, what you do? How you are going to write? You are going to write it as 1.00 meter. Sir, why not 1? Because I should retain the significant digits, no? But so like the scale, what I mean, you are converting that one. I don't think so. You are converting scale from a centimeter to meter scale. To tell that, say you have changed units, but you have used a scale which is of this kind. It should reflect what happened, the significant digits here, the type of measurement you have done. So therefore you should expect. Doesn't mean that this scale can measure up to 1 decimal place. So significant figures will not change due to change in units. You are changing for your convenient, but basically where you have done measurement here and you are expressing. So when you are changing units again, what you have to be careful. So here what we have to say that one, measurement done in centimeter scale and you are expressing in meter scale. Doesn't mean that your scale can read What is the smallest length it can read now? 0.01 meter. Come for this. What is the smallest length you can read? 1 centimeter only, no? 100. Next what? 101, 102, 103, like that. That's what this scale, no? And what is 1 centimeter? 0.01 meter. Okay, fine. So therefore, what will happen? So when you change unit, significant digits will not change. The reason for that, you should reflect what type of instrument you have used in your answer. That's why we are retaining that one. So if you write 1 meter, tell me, I think, is there any problem? Sir, 1.00, what is this? Let me write only one. Let's see. Who will oppose me? Nobody will oppose. You are called as a stupid. 1.00, there are 3 significant digits are there. These are significant. That one. But if you write 1 meter, what you are saying, that one? Totally wrong, no? That is. So therefore, this will be wrong. So I'll take it out. So suppose, say, sir, like I have 1 meter. This, I think, why scientific notation has come into picture, that I'm trying to explain here. So I have 1 meter. So what you're going to convert? 100 centimeter. Okay, tell me, like, how many significant digits are there? 1. But how many are there? 3. So this is something wrong, no? So tell me, what shall I do? Shall I write 1.00? So it's a big problem, no? Again. So to overcome this, what happened? What we do is, like, this should be written as 1 into. Okay, look at this. This 1 will indicate. I think I'll write 2. So some 3 will write it. Now, this 3 will indicate the number of significant digits. How many are there? How many are there? So it is like only 1 significant digit. So that's all. So which one is correct? This is correct. This is wrong. So 3 meter, 300 centimeter, S correct. But you should express in this one. So got the idea why significant digit, why the scientific notation again we are bringing into picture. If it is, say, like a 31 meter, convert into centimeter. How we should express? This should be 3.1 into 10 to the power of 3. Is it justified? So how many significant digits are there? 31. So 3.1. Quite 2 significant digits are there. So this will be wrong here. So I think this, when you're converting the significant digits, when you're converting converting it to one form to another form, this is what going to help you a lot. Okay, let's go for one more. Kgs, I'll bring it. Convert this into grams. So 2350 grams. How many were there? 3 are there. So now how many it has become now? 4. But 3 significant digits are there. So therefore, what is the correct method? Correct method is 2.35 into 10 to the power of 3 grams. This is correct. This is wrong. There's a measurement done. What is the rule? The value, the base should lie between what? From 1 to should be less than 10 or greater than or equal to 1. You should not write 31. 31, you should not write it. 31 into 10 to the power of 2 will be a wrong thing. I agree this. And just simple ideas, nothing to do that one. Okay, now after this, we'll go for rounding off method. Now suppose a first case. Just I'll attend one call. Huh? Some doctor has called. Okay, now we'll start the rounding off. So first say some 4.832 is there. So this is number to be dropped. I'll just write in red color. Huh? What does it mean? Number to be dropped off. Because in calculations, the necessity occurs to be dropped off here. So what to do now? If the digit to be dropped is less than 5, then the preceding digit is left unchanged here. So what is the rule? I'll first, I think we'll write a rule, then I'll come to this one. First one, if the digit to be dropped is less than 5, then the preceding digit is left unchanged here. Okay, now number to be dropped is 2, it is less than 5. So what is this? This will become 4.83. Okay, this one I'll give one more. Suppose like if you have some 3.84 is there. So this is to be dropped here. So why you are dropping, I'll tell you that one. Why we have to drop in necessity arises. So therefore we have to take it like this. So this will become 3.8 only. Okay, next thing. If the digit to be dropped is greater than 5, then the preceding digit is raised by 1. The preceding digit is raised by 1. Okay, no, 6.487, I'll write. Just some. Nearby my neighbor got tested positive, so then everyone is scared now. So that was the thing. So he don't want to go to hospital and little bit serious. They won't admit in hospital. So it is becoming big issue. That's why I had to just went there and came. Okay, we'll continue now. If the digit to be dropped is greater than 5, then the preceding digit is raised by 1. Okay, now the digit to be dropped is 7. Oh, sorry, digit like it to be dropped is 7. So the preceding is what? This 8 is the preceding one. I think I'm writing preceding. This is to be dropped. I'll shift down. We'll have enough space to scribble. To be dropped. And this is a preceding one. So what shall I do now? The number to be dropped is more than 5. The preceding should be raised by 1. 6.4. Sir, I will drop this 9 also. That will decide how many numbers to be dropped, the calculation. So just I'm making a rule. So I'll drop 9. Okay, like that I'll continue. Okay, just wait, like what numbers to be dropped, the calculations are going to tell us. There's a rule, I'm just telling this one. Now, if the digit to be dropped, if the digit to be dropped is 5, okay, can you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now we'll continue. No, if the digit to be dropped is 5, followed by digits other than 0, then the preceding digit is raised by 1. Okay, this one, if the digit to be dropped is 5, followed by digits other than 0, then the preceding digit is raised by 1. So what is the meaning of this? So I'll go for 16.351. So this has to be the 1, this is to be dropped. Okay, I'll put like this. So then if I do like this, 16.4, it will come. The preceding, this called as to be dropped. This is what? Preceding. Other than 0, then the preceding digit is raised by 1. If the so next put, okay, one more. If the digit to be dropped is 5, followed by one more. No? It should be like this. Huh? This also to be dropped. That 5 and 1 are to be dropped here. The 5 1 are to be dropped. Then what when the preceding should be the other one. If the digit to be dropped is 5 or 5 followed by zeros, then preceding digit then the preceding digit is left unchanged if it is even. Okay, example is, let me take this one, 3.250. So what are the to be dropped here? 5 and 0 are to be dropped here. So then this will become 3.2. Okay, I'll give another things. One more example I'll give it. This little bit difficult for you. It is say like a 13.8. 0.250. The 5 and 0 are to be dropped here. I think that's just simple rules, huh? Nothing being. Okay, this one. Next, one more thing. I think we'll wind up this. Same sentence. Huh? We'll copy this. Followed by zeros, then the preceding digit is raised by if it is odd. Okay, I'll take example of 3.350. So 50 are to be dropped here. So this will become 3.4. Okay, I agree this. So that this will be 13.25. This I'll make it 7. Then this will become 13.8. Okay, these are the number like, so if the number is greater than 5, the preceding should be raised by 1. Number is the number to be dropped is less than 5, the preceding should not be raised. If the number to be dropped is 5, followed by digits other than 0, then the preceding should be raised by 1. If it is followed by 0, then again condition will come. Is it even or odd, the preceding? Based on that, this is a rule. Okay, now again in calculations, what we have to follow. SGF in calculation, significant figures in calculation. And now, when we are adding what happened, we have to search for least decimal places. In addition, what happened, we should go for the least decimal places. So how to do that addition? And now, once again, so why that rounding off all that you can clearly see now. Scroll up. Okay, that one, yeah. Okay, anybody taking printout? Do take printout. Okay, no, so I'll go for it. No, we'll finish off at least this topic. It's taking more time. Significant figures in calculation. First, addition, subtraction. What rules I should follow here? So suppose we have 41.348, 2.16, 1.3. I have to add up all these three. Then when you are adding or subtracting, you have to retain the least decimal places in the sum or in the subtrahend, that one. In the final answer, the least decimal places should be retained. So which particular number is having three quantities I'm adding. So 1.3 what pen, this is having least significant digits, no? How many are there? 3. So what are the numbers to be dropped off? So I should drop this, I should drop this, I should drop this, or else I think I can only shade it. What are these red colors I'm putting that one? These are the numbers. So what happened? That has to be dropped off. This is a number that has to be dropped off. So therefore this question this will become now. Now 8, I'll drop it. So after dropping 8, how much it will become? 41.3. And the number to be dropped is greater than 5. The preceding should be raised by 1. So 41.35. Again, what is the problem? The 5 should be dropped off, no? Because the least decimal places I should retain. So then this should be 4, and the number to be dropped is 5, and the preceding digit is odd. So therefore this will become 41.4. The number to be dropped is what now? 6, and it is greater than 5. So the preceding should be raised by 1. So this will become 2.2. Then you should add, some books I don't know, they're adding, then they're doing operation. I think that's a wrong. You have to do performation like this. Okay, now we'll add up 4, 2, 3, this is 9, 2, 3, this will be 4, this will be answer. Okay, let's see that there's a procedure. So let's see that another, so some books they're given, definitely I can say it's a wrong thing. We should not do like this. So this is 8, 4, 6, 0, 1, 3, 3 plus 1, 4, 4, 5, 8, 8, this will be 5, 45. 45.808. Then least decimal places I should retain. So the 8, I'm going to drop it. It's greater than this one. So what is our answer will come? So you look at our answer. This has to be dropped. No? I should retain the least decimal places in the answer. So this will become 45.81. Again, 1, it is less than 5. The number to be dropped is less than 5. The preceding should not change. So final answer will be this much. Look at the answer. This is correct. This is wrong. You should not do like this. The rule book says this one. But which one is nearer to the answer? In fact, this is near to the answer. (44.9), 45.8. So which is near to answer? This is near to answer. So we'll get tempted. Okay, there should be the thing, that one. Final. But there's a wrong thing. So first what happened? The least decimal places, you have to do that one there only. Then you have to do this addition. I think this is what the books they have suggested. Some books I don't know, they went for this. It should be totally wrong. So in addition and subtraction, the least decimal places are to be retained in the final answer. This was the rule. Sir, what about significant digits? We are not bothered. Huh? In such operations, we may lose significant digits. A 44. Huh? Okay, some, yeah. 41, 2, 3, 4. Oh, okay, fine. But this is a wrong method, anything that. So it is the books they said this one. Okay, let's do one thing. 30 minus 0.4. How many decimal places are there? 0 decimal places. So finally what happened, what we should do, 30. This you round off. The number to be dropped is what? Less than 4. The preceding should not be raised by 1. How much answer will be? 30. What is this? 30 minus 0.4. Again, you are writing 30. The least decimal places, how many are there? Here, 0. So the final answer or pen. Here, this number to be subtracted. First, you retain that one. So there should not be any decimal place. So 0.4 will become 0. 30 minus 0 will be 30. 30 plus 0.6. Least decimal places are 0. So 30, this will become the number to be dropped is greater than 6. This has to be dropped, no? 0. So this will become 1. 31. Getting the idea? So this may look strange. So 30.6 should have been the answer, but you're writing 31. Maybe some situations will becomes little bit odd for us. Okay, what is this, all that one? But as you go for higher calculations, this only what happen will help us a lot. This answer, this our final answer, and correct answer. I'm writing correct answer. Sir, what mathematics you are bringing? 30.6, you are writing 31. Maybe the calculations here looks very absurd. I'm using word absurd or stupidity. But as we go for the higher calculations there and all, in fact, this only going to help us a lot. Okay, we'll go for subtraction of some higher numbers. Sir. Let's see that. 2 into 2 into 10 to the power of 6 minus 4 into 10 to the power of 5. So we have to subtract, find the value of x. Then this will become 6 zeros, and then 5 zeros. We have to subtract here. 16, 5 zeros, okay. So, but this should not be the answer, no? Because what is the significant digit is there? Only one significant digit is there. And what is the decimal place finally? There's no decimal place, no? So therefore, now what should be our answer? You should not keep like this. You have to write the answer in this way. Now your task question. Why we should write like this? Why can't we leave like this? I think you are not supposed to this one, no? The number to be this one 1, 2, 3, 4, 5, and this has to be dropped. No, this is greater than 5, so the preceding should be raised by 1. So we'll end up here. So what is this? 2 into 10 to the power of 6. You are subtracting, and finally you are writing this one. Is it justified, or this should be the answer? Like, according to the rule, what will happen? Number of decimal places. Here also, sir, number of decimal places are there. But again, what happens? This will become like a trailing zeros. This will become trailing zeros. So that what happens? This is the correct way of expressing this particular number. Okay, next one more. 41638 minus 1321. I think let me use calculator and give this. Four one six three eight minus 1321. 40317. What should be the answer? Shall we retain this much only? There's nothing wrong, no? Don't change anything. But sir, earlier you made a lot of changes. So when I subtract here, how many decimal places are there? 0. So final answer 0. But look at here, select how many significant digits are there? 4. Here, how much? 5. And you're retaining 5. Okay, let it be, no problem. Now same thing. Okay, let me use calculator. 41638. 41638. 38. 317. Look at now. I got this one. So how many significant digits were there? 5 and 5. And finally open, I got only 3. So due to subtraction, do we lose significant digits? Yes. No problem. Due to subtraction, but sir, you only said significant digit something, they should indicate what? Like they should indicate the precision of measurement. So here what when later on I'll take it, but the rule book says that even if you lose some significant digits, okay, later. So don't try to write anything 3.13700. But at our level, I think I should end up this one only. So this should be the answer. So you should not write, this will be wrong if you say right like that. Because sir, how many significant digits are there? 5, the final answer. Because according to the rules, what happened? When you're doing addition, subtraction, the final answer should retain least decimal places, irrespective of significant digits. So let's not bother about significant digits here. Why? Again, you can say like, why you're making such a rule? To minimize error. And now next we'll go for the last one, multiplication and division. Now we'll multiply numbers. .48 0.34 into 1.2. So in multiplication division, what we should do, the final answer must have least significant figures of quantities least significant figures of quantities that are multiplied or divided. Okay, 48.34, I'm going to multiply with 1.2. Now, who is having least significant digits here? The second number, no? So the final answer, what happened? Should have only 2 significant digits. So how many significant digits are there? SGF 2. So the final answer, what happened? Should have only 2 significant digits. So like this, we have to do it. So if I do the multiplication, 58.008. Now, what are the numbers to be dropped? All these numbers are to be dropped. What are the numbers to be dropped? This one. First, I'll drop it. So when I drop this, how much it will become? Next, I'm going to drop this. The number dropped is less than 5. So the preceding should not be raised by 1. Will remain. So now this has to be dropped. So our final answer will be 58. 58.008. You should. Why only 2? Because how many significant digits are there? It is having 2. Okay, I'll give some numbers. 24 into 6. Okay, try this. Okay, try this.
One into 10 power 2.
You may get disturbed. That's why I'm muting it, because a lot of disturbance is going on. That's why I'm just muting it. Okay, no. 24 into 6. Anybody? How much this will be?
144. 144, sir.
144. Yeah. But how many other? Only one significant digit, no? So therefore, I should. What are the numbers to be dropped? 4. I should drop it. Then it will become. I think I'll come this one. So this will be 4, 4, 1 into 10 to the power of 2. It should be. Sir, how come 144 you are making 100? This is too much. I'm really want to trouble you. That's why I just picked up such a things and all. Because how many significant digits are there? Least is how much? Only one is there. So 144. So better to write 144. No, the final answer should have least significant digits here. How much? Only one. So therefore 1, that one. So this will indicate that significant digit here. It's very difficult. Okay, please do digest. I think better to take calculator. How many are there? 3 significant digits are there. So this will become how much? 1.49. So how it has become, it will be like this. The number to be dropped is 4, which is less than 5. So the preceding what will not be changed. Okay, this will become 140. Again, this has to be also should be dropped here. Because one significant digit I should expect. So therefore, I think if I show in order, it will get confused. That's why I directly wrote this one. So these two numbers are to be dropped. Actually, there's a rule. So here now 1.49. So all these things are to be dropped. The dropped one I'm putting. Okay, let's go for the division also. 125 by 25. This will become 5. So shall I write 5 or 5.0? 5.0 is what you have to write. The reason, how many significant digits are there? 2 are there. So final answer I should retain 2. But sir, only 5 we got. Okay, why can't we write 5? Because I should reflect that the least significant digit. So this should be the 5.0. No, how many other least significant digits are 3. So I'm going to drop it. So how much it will become? And the number to be dropped, again, this, okay, we'll do one thing. I'll later on, I'll shade it. It will be. And again, 0, I'm going to drop it. Again, this. So what are the numbers? We have to drop it here. Then I dropped it. Then next I'm going to drop this. Next, after this, I'll drop it. And finally, we'll get this one. This should be our answer. So is it okay now? So in an order, I'm dropping it here. Now number to be dropped. Okay, there's red color. Okay, fine. It's less than, it's more than 5. So the preceding will be raised by 1. It will become 3. The number to be dropped, this is less than 5. The preceding will not change. The number to be dropped is 0. So no change for this. And the number to be dropped is more than 5. The preceding should be raised by 1. This will be our answer. Well, why we should do like this? Why can't this be answer, sir? This is correct. In fact, calculators show this and you are writing this. Tell me which is correct. I'm using word exact. Which is exact? This is exact. Then why we are preferring this? If you do one thing, up to 3 decimal places, if you just take it out 8027, you get 9.6. But compared to 19.6, 19.7 is what? Better answer, no? If you directly take out this 8027, then you write 19.6. But 19.7 is better, no? So that's why we are dropping this one. That's why we are going for the final answer should have least decimal places. Hope all of you, you're able to understand what I mean to see. The final answer output should have least decimal place, the least significant digits here, not decimal places. No, we are not bothered decimal places here. Multiplication division should bother about significant digits. Addition subtraction should bother about least decimal places. That's what the rule says here. Agreed, all of you. So these are some general rules are there. I think this will be very, very problematic for you in exam because students often get confused. So I suggest students better to take different cases and analyze here. So this will be very troublesome in exams. The answer will be given like this. Huh? Students, they do fight with me, sir, how come? But the final answer is given like this, especially in integer type. Do express final answer in due regard to significant figures. Means your answer should be this one, not this one. 20.6, no, that is not answer. 30 is what your answer. Express your final answer due regard to significant digits. If they say like this, your answer should be this one only. I'm making things clear. So either addition, subtraction comes, everything you have to be very careful. So now you do have many questions in especially integrated icon book where they give dimensions of object, then they'll ask you to find out the volume. I think in calculations, you should be very particular about multiplication, division, the significant digits. When you're doing addition, subtraction, you should bother about what? Like the decimal places. And these are the general rules. Now, once again, I summarize why significant digits. Again, why significant digits? The basic idea. To express the precision of an instrument. So what significant digits? I think I didn't write. Yeah, the measurement observed should be entered in such a way that it should reflect the precision of instrument used. Precision of instrument used here. For that purpose, significant digits are brought here. Okay, now students are really, they are asking, sir, is it what you said is correct? Okay, let's go back. Tell me, like, what is the precision of this instrument? Up to 0.001 centimeter, it will read, no? And the final answer, what you are writing? You are writing like this. Now you can ask questions, sir. At least you should retain 3 decimal places because it will reflect the precision of instrument. Tell me, like, what is all our discussion? I think I don't know how many of you thought, because I wrote that there is a golden statement. Then our final answer should reflect this precision. No? This having good precision, it should reflect here. But instead that open, I'm focusing on this. Tell me, like, here, if I do error, instead of saying 41.348, if I write 41.347, okay, no, what is the error? Or another student will say, no, sir, it is 41.349. Tell me, like, among 3, what is the error? The possible error is how much? 0.001 only. Okay, instead of 1.3, if he says that instead of 1.3, I think this will disturb your. One student will say, no, sir, it is 41.3. Other student will say that, no, sir, it is 41.349. Tell me, what is the possible error among them? One student will say, sir, 1.2. Other student will say, no, sir, it's 1.4. But 1.3 is correct. Tell me, what is the error here? 0.1. Tell me, like, which one has to be given priority? This one, no? Here the error is more, no? Here, what is error? Error is less. So now, so I should reflect, the final answer should reflect where the maximum possible error can erupt, where the maximum possible error can come into existence, due to which instrument, due to this. Getting the idea? If at all, like three students are given three different scales. Tell me like where the possible, maximum possible error can come from the third student, no? Because, and what is the error generated by this student? Because he's using a scale of 0.01. So the error by this instrument is of order this one. The error by this instrument is of order 0.1. So definitely what it showed that one. So this student what happened should be more alert. So the final answer what happened will reflect this one. So definitely what happened? The final answer what happened when I write like this, no? So I'll go for it. Oh, the three instruments are used. So definitely what happened? I should design this instrument very systematically, very perfectly, so that the error what happened should not be more. If error is there, if this instrument is not designed properly, it will generate more error. If there is error, okay, no problem. The error is of this order. So to reflect that, what happened, the three instruments which are used, this should be designed properly. To reflect that idea, we are choosing decimal places here in addition, subtraction. Got the idea? I don't know how many of you understood what I wanted to deliver. These are the three instruments are there. So the final answer should reflect particular situation where the instrument which will generate more error. So this instrument will generate more error. So what happened? To reflect that particular, this instrument can generate more error, the final answer should be designed in such a way. That's why the rule is made. So the moment what happened, if I get like this, if I solve it, no? So immediately what happened, I should focus more on this instrument design. I should design it perfectly. That's all, finish over. So to reflect that, this particular answer is brought in this way. Okay, got this. So this may, for us, it's a simple mathematics. The moment you become mechanical engineer, and when you start designing machines, everything, no? At that time, I think these are the things which will help you. And these are the things which will make you very successful engineer. This topic, errors, significant figures, everything, no? These topics only are going to help you, rather than rotation mechanics or work point G or any other thing. If you are very good in this, then you are very good. You will become good engineer. But you should understand the underlying the concept, why only. That will come by thinking, not by like a books I have not discussed. Okay, that should come. You should make observation. Okay, why only they're doing this one? What can be the reason? Okay, let me express this final answer. If I express final answer like this, then what when, okay, what is there? If I write 1.3 or 1.4 doesn't matter. If I express here answer in terms of like this, no? So then I'm not bothered about this one, no? Then if I'm not bothered, then instead of 3, if you write 5, then it will become more. Getting the idea? This one. So many students are against this one. Sir, how come this? Why you are doing like this? Okay, there is some background is there. Okay, now similarly, multiplication and division. Again, the least decimal places not, least significant digits are given priority here again, because here the possible error is more here. So this should be taken care. The possible error, instead of 6, you write 7, no, so the value will get changed. Don't say like, sir, 144, you wrote 100, 44 error is there, and you are telling, okay, very nice. This one example I gave it. In your practical applications, you don't write 144 as 100. Just only the rules to implement rules, I just picked up this particular thing. Getting the idea? This one? Okay, just I think today I'll upload almost, I think I completed errors and significant figures. One good topic got over. I'll upload questions. So do practice. You have to be very careful about these things. And they